I'd love for you to take a look at the representation I have here. Now I'm using some place value disc, but we're just going to use them as objects today. This is what I have that's magnetic. So I hope you've got some objects in front of you, and I'd love for you to represent this with two different colors, showing 8 on the top in one color and 4 in another color. Now we've talked about ratio. I'd love for you to talk to me about how you could use ratio to compare the number of blue circles to green circles. And I want you to expand upon what we learned in the ratio video, and I want you to tell me more than one way. So more than one way that you could describe the number of blue circles to green circles. Go ahead and pause the video and try it out. Hopefully you've got a few different answers here. So I want us to talk about it. So if I'm comparing the number of blue to green, and again, I'll get my two different colors here. Let's do blue. I know that I have 8 of them, so we could do 8 to 4, right? And I'll just do so 8 to 4. That one's pretty obvious, right? That's one we learned in our first video. We've got 8 to 4. So here's my question. What is another way to compare these? Well, let's say I decided to put them into groups. Let's say I decided, I'm actually going to move these guys here, move these guys here, scoot these over, scoot these over. There we go. And if I wanted to, I could draw a little rectangle around them, but I'm actually going to leave it like this. What do you notice? I see 4 groups this time and 2 groups. So I could record this ratio as 4 to 2. Do I still have the same number of blue circles to green circles? Because I didn't change that, right? We had 8 and we had 4, and we still have 8 and we still have 4, but they're grouped. I grouped them into groups of 2. So now I'm saying that there are 4 groups of 2 blue compared to 2 groups of 2 green. I really had to think about that. Is there another way? Let's think about this. Let's say I wanted to group them into groups of 4. Now, how would you record this? I would say that I have a ratio of 2 groups of 4 to 1 group of 4. These are all equivalent ratios. Now you've talked about equivalent fractions. These are equivalent ratios. They are equal to one another. They just look different. It's a different representation. Now the other thing I'd love for you to notice is, what do you notice about these numbers here? They all have some things in common. I notice that 4 is a factor of 8, and so is 2. I notice here that 2 is a factor of 4, and 1 is also a factor of 4. So let's go back really quick to our original ratio that we had. We had 8 to 4. If I wanted to figure out an equivalent ratio that is in its simplest form, that means grouping it into the least number of groups while staying equivalent to this. What could we do? I can look for, let's look here. What did we do? How did we get to the one, that would be this one, that has the least number of groups? We made it down to 2 groups of blue and 1 group of green as our ratio. So how did we get here? Well, if I think about how 8 can be divided to get to 2, I know that I just need to divide that by 4. What happens if I try to divide 4 and I want to get it to 1? What do you divide it by? By 4. So just like when we did equivalent fractions and we divided or multiplied the numerator and the denominator by the same number, when we have a ratio, we can do the same thing. If we divide each of these terms by 4, which happens to be, and I'm just going to go ahead and put this there, the greatest common factor, we will end up with the ratio in simplest form. So we've talked about 2 things here. Equivalent ratios and how to use the greatest common factor to write it in simplest form. Still the same, still equal, but represented in a different way.